Hello, Machine Shop math fans. We are back again. This is not video 5. This is going to be video 10, part 1. These notes were done back in the spring when we were forced to put this course online for the first time. We only had 6 weeks to do it in. So this is not video 5. This is not video 5. This will be theoretically in week 4 and week 5 folders in D2L. Week 4 and 5, it looks like I am going to use the week 4 and 5 folder for the trig. Exam 3 has a lot of moving parts. It's going to be a pretty extensive exam. Exam 4 will be nothing more than a complex homework assignment. It should be easy to do. I'll send everybody an email explaining that. I will strip Unit 44 out of the old book, and I will put that up there for you to read if you want. So, this is the start of the review and lecture that will deal with what you're going to have in Exam 3. First thing we need to do is we need to talk about angles, degrees decimal and degrees minutes and seconds. There are two ways to measure an angle. You can measure it in degree decimal or degrees, minutes, and seconds. Now, 1 degree is equal to 60 minutes. 1 degree equals 60 minutes. 1 minute of angle is equal 60 seconds. Now, those of you who are doing any kind of precision shooting probably understand an MOA, what's referred to as an MOA, a minute of angle. MOA, a minute of angle. And you probably, if you're into long-range shooting or military shooting, you probably have heard of the mil-rad. The mil-rad. That's 1/1000th of a radian. I'll do a separate video on that just for giggles. All right. So, for target shooting and more precise shooting, you really want an MOA. For just general ranging and sticking a adversary, a mil-rad's just fine. In the video, I'll explain the difference between the two. I've got scopes that are in mil-rads, and I've got scopes that are in MOA, and I don't have a problem converting back and forth. All right, so back at the mission at hand. The mission at hand is to get you to understand how to use degrees, minutes, and seconds and degrees decimals. Surveyors will use degrees, minutes, and seconds. All your land plats are done in degrees, minutes, and seconds. Old navigators who use old sextants, the sextants are in degrees, minutes, and seconds. And the manual vernier protractors that we use in machining are in degrees, minutes, and seconds. However, you don't put degrees, minutes, and seconds in a CNC program, and you don't plug it into a DRO. You plug in degree decimal. So, we need to understand how to convert from degrees, minutes, and seconds and degree decimal and back and forth. Now, there are programs that will do this for you. You can go out to Google, and here's one right here. Let's see, where is it? This one right here, rapid tables, degrees, minutes, and seconds to degrees, decimal degrees to degrees, minutes, and seconds, and you can swap it back and forth. Some of your calculators will have the buttons on them to do that. The Casio that I listed in the syllabus has a button. It's got a button on the calculator. It's got a 0 and one of these gizmos and one of these gizmos and a little arrow across the top. So you can plug in degrees, minutes, and seconds. Hit shift, hit the arrow, it converts it to decimals, or plug in decimals and hit the button, and it'll give you immediately the degrees, minutes, and seconds. But we're gonna learn how to do this by hand. It's no big deal. It's real simple. And the TIs have one that is DMS DMS, and DDM, or something like that. So your calculator, your mileage will vary depending on what calculator you have. The Windows calculator does not have that function at all. So we're going to do this by hand. All right, so let's start off. We have an angle CAB. Now, I always like to put the vertex, or the angle we're talking about, in the middle of the description. So we have angle CAB. A is the vertex. And we're going to say that this angle, we're going to start with degrees, minutes, and seconds. All right? Remember, 1 degree is 60 minutes. 1 minute is 60 seconds. All right? So, I thought I'd cut this off. Well, I'm using the internet, so we'll just let it go. All right, so let's start off with 46 degrees, 24 minutes, 33.55 seconds. Now, to go from degrees, minutes, and seconds to degrees decimals, we work from right to left. In other words, this is our right, this is our left. This is my rifle, this is my gun, right? This is the right side, this is the left side, and we go from right to left, all right? So the first thing you're going to do is what? We got to convert the seconds to minutes. And so there are 60 seconds per minute. So we're going to divide our seconds by 60, and we get 0.5591666, there's that number again, 666 minutes. We're going to take that decimal minutes and we're going to add it to our whole minutes. Remember, we had 24 minutes over here. So now our angle is 46 degrees and 24.559166666 minutes. It's not seconds. We converted our seconds to a decimal minutes or fractional minutes and added it to our whole minutes. Now guess what we're going to do? Yeah, the FBI's already figured this out. All right, we're going to take our minutes, which is now 24.559166666, and divide it by 60 minutes per degree. 60 minutes per degree. And guess what we're going to get? We're going to get a decimal or fractional degrees. All right? So if you divide 24.559166666 by 60, you get 0.409319444. If you're not doing this on your calculator, you are hurting yourself. I'm telling you, you're setting yourself up for failure. You follow along and repeat these steps. Pause the video and do the math on your calculator. It's practice. It's just like dry fire practice. All right. Now we're going to take this decimal degree, or this fractional degree, however you want to call it, and we're going to add it to the whole degrees. So now we've just converted our degrees, minutes, and seconds to degree decimal, and that answer is 46.409319444 degrees. All right? So we've solved that problem. We went from degrees, minutes, and seconds to degree decimal. Now we want to go back. Let's say we were given degree decimal and we want to go to degree, minutes, and seconds. Well, guess what? Now you're going to work from left to right. You're going to leave the whole degree alone. You're going to strip it out. So you got 46 degrees. This 0.409319444 degrees is a fractional degree. You're going to keep the whole degree. All right? You're going to keep the whole degree. Then you're going to take the decimal and you're going to multiply it times 60 this time, and you're going to get 24.559166667. Got it? Look up here. All right? Now, why did we get a 6 here and a 7 here? It's the algorithm in the calculator. Don't worry about it. Don't lose any sleep over it. Second thing you're going to do is you're going to keep the whole minutes. So you're going to pull the 24 minutes out, and then that leaves you with the fractional minutes, 0.559166667. Now what you're going to do is you're going to multiply that. You're going to multiply this times 60, right? That's 60 seconds per minute, and you end up with 33.54999999999999, right? So, guess what? That's pretty darn close to 33.55, right? Okay, so then that comes over here, and now that becomes 33.55 seconds, and guess what? There you are. That's where we started from. It's that simple. I cannot make this any harder. I cannot make this any harder. Even if I wanted to, I couldn't. Well, maybe if I spoke in ancient Greek or something, y'all would have a hard time, but we're not going to do that. All right. So that's it. I can't make this any harder. Now, let's go over and use that little program that's over on Google. We got decimal degrees, right? We want decimal minutes. So what did we say? We had, what the heck was it? It was 46.40931944 degrees, right? We want to convert that to degrees, minutes, and seconds. Well, looky there. 46 degrees, 24 minutes, and 35 seconds. Wow, isn't that special? Isn't that special? Wow, that is pretty special, man. All right, so let's swap this around. All right, here's degrees. Okay, 46 degrees. How many minutes did we have? We had 24 minutes. How many seconds did we have? We had 33.55. Convert it to decimal degrees. Bingo, there you are. 46 degrees, 24 minutes, and 33.55 seconds. All right? Again, I can't make this any harder. You know, I'm a simpleton. If you hadn't figured that out by now, I like to do things simple. There's no reason to have to work hard, all right, when you can work smart. So we measured this angle here. CAB is the angle. So we're going to measure angle A. And then that's what this is. That's what we just measured. That's what we just measured, okay? That's what we just measured. That angle right there. Now, you can play this video back. Again, I keep saying that because some of y'all are not going to do that. But that's okay. You want to be a winning nut? Be a winning nut. All right. So we want to read and understand geometric principles. That would be Unit 46. I'm going to go ahead and put these Units 44 and 46 up in the week, probably week 4. Chapter, well, it'll be, I'll send you an email. You'll already know by now. All right. Now, we've already talked about the types of triangles, yes? Of course we did. All right. We went through all of that. All right, we talked about two angles are complementary if their sum is 90. Two angles are supplementary if their sum is 180. So this is a repeat of a previous video. Angle C, AB. All right, CAB or angle BAC. Always put the A in the middle where the angle is. I just call it angle A. I already told you that. Acute means it's less than 90. Right means it's a 90. Obtuse is greater than 90 and less than 180. Straight is 180. A reflex is 180 to 360. And then a circle is 360 degrees, and that's a no-brainer. We don't call it an angle. We call it 360 degrees. A circle. Yes? Outstanding. Now, Unit 47 of the old book gives you the types of triangles, but I gave you that in the master formula sheet, did I not? Of course I did. There are all these pages of triangles up in here. So this is, again, a repeat. If you haven't gone through and printed this and made this your little Bible for this class, then God have mercy on your soul, is all I can say. You know, it can lead you to water, but it can't make you drink. Even if I tied an anvil around your neck, all I'm going to do is drown you. If you don't want to drink, you'll just drown, right? So all these angles, we talked about the triangles, right? Okay. Foostrums, there's your triangles. We talked about the Magdaddy, the right triangle, Pythagorean theorem. We talked about circles. Now it's just a matter of doing the mathematics with it. Here's the rules of the road for geometry. If you haven't read this, you're hurting yourself. This is America. You have the right to do that. You got a lot of stupid people in this country. You got a lot of stupid people in the world. All right. All right. Then we get into trigonometry, which we'll talk about that later. So let's go back to the review. Now, this review is going to be in multiple parts like the other videos. And you'll just have to get over it. All right, we talked about scalene triangles, isosceles triangles, equilateral triangles, and then we talked about the Magdaddy triangles, the right triangle, yeah, and the Pythagorean theorem. Now, if you'll remember the Wizard of Oz, when the Scarecrow got his degree, his diploma from the wizard, his PhD of thinkology, he quoted a geometric theorem, and it was wrong. He was trying to quote the Pythagorean theorem, and he got the wrong triangle. So even educated people screw up, okay? They did that intentionally in the old movie, by the way. All right. So let's get with the, we're going to work up some areas of triangles. Remember I told you that there was a fellow by the name of Heron? He taught about 70 AD at the University of Alexandria before the Romans burned the library there. Well, the normal area of a triangle, the normal formula, it's on your formula sheet, the area of a triangle is 1/2 the base times the height, right? Okay. So if the base of the triangle is 12 inches, this being the base, and this being the height, and this being the base, then it's 1/2 the base times the height. Okay? So the area is 1/2, 12, which is the base, times 24, which is the height, and that's 144 inches squared. It's area, right? So it's got to be square something. All right? We already said this is inches over here. So, and it doesn't matter what kind of triangle. If you can figure out what the height is, and you know what the base is, and you know what the area of that triangle is. Well, what happens if you only have 3 sides? You only have the lengths of 3 sides, but you don't have the height. So we've got a triangle that's a 4-3-5 triangle, right? So all the sides are different length. All the sides are different length. We can use Heron's formula, and here is Heron's formula. Heron's got 2 parts to the formula. You got to figure out your constant S for the triangle first. That's why I said first right here. See this? First. You do that first. You do this second. All right? Okay. And you thought this was hard. So you add the lengths of all the sides up. So in this case, it's 5, 4, and 3. Well, 5, 4, and 3 is what? All right, it's 12, yeah? Okay, outstanding. All right, you take half of that, and that gives you your constant 6. S is 6, all right? So you take 6, you plug it into this formula. See, there's S and S and S and S, right? Okay. So it's 6 times, here's a parentheses, so you do what's in the parentheses first, yes? All right. Then after, and everything's underneath this radical sign, so you got to do everything in here first. So then you keep going into the side. We do the parentheses. So 6 minus 5 is 1. Yeah. Okay. 6 minus 4 is 2. 6 minus 3 is 3. So we got 6 times 1 times 2 times 3. Yes? Yes. The answer is yes. Oui, si, da, ya. All right. So 6 times 1 is 6. 6 times 2 is 12. 12 times 3 is 36. You then take the square root of 36. You take the square root of 36, and what do you get? You get 6. You get 6 inches squared. All right? Now what is this? This is 6 times 6. This is inches times inches times inches times inches, right? Okay. So that's inches to the 4th. You take the square root of it, you get inches to the squared. All right. Just accept it. Believe me. Accept it like the changing of the tides. Okay? All right. So there's your answer right there. So the area is 6 square inches. 6 square inches. All right? Okay. All right. Let's move on to the right triangle. All right. Now you remember in that formula sheet, remember in the formula sheet, the Mac Daddy formula sheet, remember this? Remember this? I like using the Edge to open up PDFs because I can draw on them a lot easier than Adobe, but the bloody thing takes so long to load. It's not like a regular thing. Remember this? Remember this? This is your right triangle, you Mac Daddy, right? I explained all this to you. Here's all the formulas, blah, 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 right? Okay, all right, good. Outstanding. I guess now would be a good time to check to make sure I didn't screw those up, right? Well, looky there. Got them right. Woo! Wow. Man, Annie M. All right. Let's go back over to our notes. So we got a right triangle. Pythagoras, c squared equals a squared plus b squared. Now you already know this because I already told you in the other video, and it's in the formula sheet, that excuse me, 4, 3, 5 or a 3, 4, 5 triangle is a right triangle, always and forever. But let's pretend we don't know that right now. Let's just go back and, good God, where's my cursor at? There it is. Okay. So C is the hypotenuse. C is the hypotenuse, right? C is the hypotenuse. C is the hypotenuse. C is the hypotenuse. The hypotenuse is, there we go. Oh, come on. There we go. The hypotenuse is always across from the right, the 90-degree angle, right? That's 90 degrees. All right. So the hypotenuse, okay. So 4, 3, 5 is a right triangle. Okay, remember that. So you got that in the notes. You've also got it in the review. All right, so let's play around with this sum. All right, so side A is 3 inches, side B is 4 inches, side C is what? So let's pretend we don't know what it is, okay? Let's just pretend, all right? So let's work up Pythagorean's theorem. So 3 squared, so we're going to look for side C. So that's a squared plus b squared, right? So a is 3 and b is 4. So 3 squared is 9, 4 squared is 16, so 9 plus 16 is 25. Oh, Annie M, look at this. The square root of 25 is 5. Yes. Oh, thank you, Wizard. I've got the doctorate of thinkology. All right. So now, so it's 5. And it would be 5 inches, yes? 5 inches, because our units are in inches. All right, so it's 5 inches, not 5. It's 5 inches. So, all right. So the triangle is a right triangle always. Now let's look at the area. 1/2 of the base times the height. Now the base is 4. The height is 3. So, all right. So let's look at the area, because this is a right triangle, yeah? So this would be the vertical. This would be the vertical. Vertical, man. Yeah. Everything be Ari. Like Brother Bob Marley. Everything be Ari. That's your vertical or your Y. That's your horizontal or your X. Okay. So the base times the height, that's 12 minus, and divide that by 2. 1/2 the base times the height is what? It's 6. Wow! Look, Heron's correct. Well, I am sure old Heron is just happy as all get out. All right? Wherever he's floating around the universe right now, that we just proved that Heron was correct. All right? Now, again, this is not video 5. This is not video 5. It's not. This was for the spring plague thing when we had 6 weeks because they wouldn't let us start. I don't know why. Everybody's got a virus software on their computer. But they made us all go online. But whoever said humans were intelligent, right? So that's why Peter Pan didn't want to grow up, I guess. He didn't want to be an adult. All right. So we're going to do trigonometry next. Now, this video is running about 26 minutes so far. So, I think I want to save part 1. I'd like to do all of trig in one video, one long video. So let's go back up here and see if we didn't miss something in this short video. We got the right triangle again. This is a repeat. This is a repeat. We talked about the right triangle. We talked about how to measure angles. Again, this is back on the other angle sheet. Degrees, minutes, and seconds. I'd play around with this. This is really simple to do, right? So, I don't think I really need to do another one of these. I think we kind of beat this up. If we want to go, again, like I said, we start off with degrees, minutes, and seconds, then we're going to work right to left. And we divide the seconds by 60. Take that decimal and stick it over here with the minutes, and then divide that by 60. Then take that decimal and add it to the degrees. And you've got your answer in degree decimal. And going back, you strip out the whole degree, set it off to the side, it's 46. Multiply this decimal here by 60. Take out the whole minutes, 24, and stick it over here with the degree. So you got 46 degrees and 24 minutes. And then you're left with this decimal, and multiply that times 60, and then you end up with your seconds. And that's 33, and just round it to 2 decimal places, and you get 33.55. Okay, or you can go out and either use your calculator if it's got the magic button on it, or just make sure you do it right, or use a online formula. So we're running up on 30 minutes for this video. Why don't we stop here, and then we'll pick up with trigonometry with the next video. Now, I don't want any of y'all getting freaked out over trig. It's just mechanics. It's like picking up a screwdriver or a micrometer or a crescent wrench. Once I show you how to do it and use the buttons, you're going to be okay. All right? All right. So, let's just end this here. All right. I'll see you on the next video. All right. Bye-bye.